Today we're diving into the heart of German motorcycle excellence with the BMW R60/5 engine rebuild. In this video, I'll go through the entire assembly process, covering every step from beginning to end. Throughout the video, I'll emphasize the essential steps to ensure everything functions as intended, offering numerous insider tips for a bulletproof engine. Additionally, I'll provide valuable insights to specific components and disclose all torque specifications. To make this assembly easier for myself, I mounted the engine block to this custom-made engine stand. This way I can access every side of the engine without any issues. If you want to know the details on how I built this, let me know down below in the comment section and I can always make a separate video about this. But now let's shift our focus to the crankshaft and its corresponding components so we can start with the assembly process. Displayed on this table is a comprehensive lineup of parts ready to be inserted into the engine block. Starting on the far left, you'll notice the main bearing retainer, which has already been equipped with the main bearing insert. I've previously covered this assembly in a dedicated video, which you can watch by clicking right here. Next up, we have the crankshaft. The way the crankshaft is laid out, we have the front of the crankshaft on the left side and the rear of the crankshaft on the right side. Now let's shift our focus to the rear main bearing. This is a brand new rear main bearing insert that still has to be pressed into the engine block. The location of the rear main bearing will be within this bore, and it has to be pressed in with a custom tool, and that's what I put together right down here. Next to the main bearing, we also have two thrust bearings that play a crucial role in preventing the crankshaft from drifting axially and transferring loads applied to the crankshaft. To secure these thrust bearings, they are located with two dowel pins on the rear of the engine block. These two dowel pins will be located within that bore right there and within that bore right there. Moving to the far right, you'll spot the flywheel. This flywheel has two very important features. One surface serves as the face that interacts with the thrust bearing, while the outside diameter is designed to accommodate the shaft seal. Here you can see the shaft seal that will eventually ride on that ground surface. To install this rear shaft seal, I'll be using this special tool. On this table, there are exactly 3 specialty tools for this assembly, so if you guys have any questions about them, let me know down below in the comment section, but I'll really try my best to explain exactly how they work. To kick off this assembly, I'll be installing a brand new rear main bearing into the engine block. Before I do anything, I want to mention that this rear main bearing is larger in diameter than the engine block bore. Now what that means is once we install this rear main bearing, it will be held by friction. This can also be called interference fit. From what I measured with an inside micrometer and an outside micrometer is that the main bearing itself is roughly 3.5 thousandths of an inch larger in diameter. To simplify the installation of the rear main bearing, I created a custom shop tool. It compromises of a 1-inch shaft approximately 4 inches in length with a 1-inch long step at the rear end. This design accommodates a larger 74mm disc featuring a machined step allowing precise centering within the engine block from the inside. The extended portion of the shaft protrudes towards the rear of the engine block, enabling the attachment of an aluminum slider perfectly fitting over the 1-inch shaft. This aluminum part incorporates a machined step tailored for the rear main bearing. By placing the rear main bearing directly over this step, it securely seats against the shoulder. Consequently, the aluminum part can be positioned directly onto the 1-inch shaft. Visualize the engine block material within the space of the assembly. To complete the process, pressure is applied to the aluminum part from the rear, effectively pressing the rear main bearing into the engine block. Additional travel can be achieved by introducing another spacer, such as a radial bearing or an extra washer. Now let's start with the rear main bearing installation. The rear main bearing has successfully been installed within the engine block and everything went together really well with the custom tool I built. Now the engine block itself was still a little bit warm, so I let it cool down and reach room temperature. At the moment, the engine block and the rear main bearing read 18 degrees Celsius, so it's the perfect time to measure the inside diameter of the rear main bearing. It's really important that you measure the inside diameter of the bearing to the outside diameter of your crankshaft journal, which will essentially be your oil clearance. The The value that you receive has to be within the factory specifications, or else you'll probably have a very sloppy engine rebuild. Now, instead of always just popping everything up on screen, which I'll still do in this video, I actually put together an engine build sheet. This is compatible for all BMW/5 models, so if you have an R50, an R60, or an R75/5, you can use this 10-page document to document your whole build sheet. If you guys would like to download this BMW/5 engine build sheet, head over to my website. It's down below in the description. You guys can download this completely free at no cost. With that said, let's continue on with this engine assembly. For the next step of this engine assembly, I'll focus on the dowel pins that will hold and locate the thrust bearings on either side of the engine block. One thrust bearing will go towards the crankshaft and the other thrust bearing will go towards the flywheel. It's really important that you get the length of these dowel pins just right, because if you don't, they can damage components within the engine, which will lead to catastrophic failures. So let's have a good look at them. In the center of the screen, two pairs of dowel pins are displayed. The upper pair consists of the used dowel pins extracted from the engine block, while the lower pair comprises brand new dowel pins ready for installation. These new dowel pins are specifically modified for this application. However, I'll begin by showcasing the old ones to provide a clearer understanding. Upon inspecting the worn dowel pins, you'll observe that its tip is no longer perfectly round. Additionally, there is a noticeable cupped area on the front, worn from contact with the old thrust washer. On the flip side, the pair of brand new dowel pins mirrors the characteristics of the old ones. In the scenario of the crankshaft rotating in one direction, there's a distinct contact point on the dowel pin, towards the top on one side and at the bottom end on the opposite side of the bore. Upon inserting the dowel pin, you'll observe that the contact point embeds within the material. We want full contact between our dowel pin and the bore of the thrust washer, and obviously if it's worn that much, it will not have full contact. This means there will be excess play on the thrust bearing within the engine, which is really not good. In order to figure out the length of dowel pin you need, you're going to take 3 measurements. One measurement will be of the engine block. That will be the thickness between either side of the mating surface of the thrust washer. Then you need the thickness of the front thrust washer facing the crankshaft, and you also need the thickness of the rear thrust washer facing the flywheel. From what I measured, the dowel pins should be 26.33 millimeters in length, and obviously that's an odd number, and I don't think anybody else would manufacture that. Nevertheless, the dowel pins that BMW has to offer are 26.8 millimeters in length, so even if I would order the original or OEM dowel pins, they would still be too long, which means I would have to modify them. So I just went out there and bought M4 by 30 dowel pins, and I just shaved them down to my desired length of 26.2 millimeters, just a shade under the size that I measured. That way they will not protrude out of the thrust bearings themselves. Now, when we have a closer look at the new dowel pins, you'll see I left the factory finish, which is a half round finish on one side. That's the side I'm going to be tapping on, and on the other side I created a chamfer. This way they will drive into the engine block much easier. Prior to the installation process, I'm going to heat up the engine block, making sure I do not touch the main bearing. While I drive them in, I also want to make sure that they're sticking out on either side of the engine block by the same amount. This way they'll have the same amount of contact on each thrust bearing. So let's get to the installation process. The dowel pin installation process went super smooth and I did not have any issues. As you guys know, on this table, the thrust bearings will be located on both dowel pins on either side of the engine block. Now, it's really important that you get the right thrust bearings because they are available in different thicknesses. The ones that I have on this table are color-coded red and green. You can also get blue ones or even yellow ones. So the combination of thrust bearings is completely up to you, but you have to have the right measurements and the right end play to meet the service manual specifications. But right now, I'll share with you guys how you can calculate your end play prior to the installation process. Then we'll be assembling all these parts onto the engine block and checking it once more with a dial gauge. The crankshaft end play can be measured prior to the installation process of any of these parts. And in order to do that, we need exactly 5 measurements. On page 3, you'll see exactly what we need under the crankshaft end play. Over here, we need a crankshaft measurement. We need the thickness of the inner thrust bearing, which is facing the crankshaft. We need the thickness of the engine block. We need the thickness of the thrust bearing, which is facing the flywheel. That's that thrust bearing right there. And we also need a flywheel measurement, which is our depth measurement. So with these 5 values, we can figure out our end play prior to the installation process, and I'll share with you guys how that works. The initial measurement involves determining the crankshaft depth, measured from the crankshaft base surface to the mating surface of the thrust bearing. Subsequently, measure the thickness of each thrust bearing. In my case, I start with the red thrust bearing, followed by measuring the green one. As the flywheel integrates with the crankshaft base, measure the flywheel depth from the thrust bearing mating surface to the bottom inside surface of the flywheel. Lastly, gauge the thickness of the engine block. Although I lack a video demonstrating the measurement with an outside micrometer, ensure to measure the distance between both surfaces of the engine block. Once you have all 5 values, you can use the formula up above to figure out your result, which is essentially your end play. Now on page 2, you'll also see the crankshaft end play. So you'll have your metric end play or even your imperial end play, and whatever you measured can also be written in this box right here. Once you have confirmed your crankshaft end play by measuring everything, writing everything down, and let's just say you are within spec, you can actually continue on with this engine rebuild. But there are 2 more cases that you could run into, and that is you do not have enough end play or you have too much end play. So those are 2 cases. Let's just talk about if you do not have enough end play. So right in front of me, I have a red thrust bearing and a green thrust bearing. The red thrust bearing is the thinnest thrust bearing we can get, and the green one is the 3rd thickest one we can get. So in my case, this will make up the end play that I need. But if I do not have enough end play or it's just too tight and I need to actually have more end play, that means I have to exchange this green thrust bearing for either a blue one or even a red one. Depending on the measurement you receive, you can calculate the difference and figure out which thickness of thrust bearing you want to exchange that for. Now it's very unlikely that you're going to replace the red one because you can't actually go thinner than that one. So you're going to always want to replace the thicker thrust bearing in this case. Now the other issue we can run into is that we have too much end play, and that just means it's too sloppy. That means we have to add material to make that end play smaller. In this case, we can only replace the thrust bearings with thicker thrust bearings. In my case, I have a red one and a green one. Just as an example, I would rather replace the red one for a thicker thrust bearing, let's say the blue one, the green one, or even the yellow one, depending on what I need, instead of replacing the one towards the crankshaft. Hopefully with the information I just shared with you, you'll be able to replace your own thrust bearings and figure out which thrust bearings are actually needed for your application. But right now, let's focus on the assembly process. To verify the end play, it's essential to attach the flywheel and secure it to the crankshaft, but we have to be cautious during the bolting process. Notice the factory indicator mark on the flywheel. Additionally, I've highlighted it with a yellow dot. Be mindful of the evenly spaced bolt holes, as incorrect orientation is possible. In this close-up, observe the small machined radius of the factory mark, which must align with the crankshaft indicator mark, a similar feature. Failure to align these marks will result in an unbalanced flywheel, affecting the overall rotating assembly and causing inaccurate timing marks. With the correct orientation established, proceed with the flywheel assembly to assess the crankshaft end play. To assess the crankshaft end play, position a magnetic base directly on the flywheel and align the dial gauge perpendicularly to the engine block, ensuring the indicator reads 0. Proceed by moving the crankshaft forward to measure the end play, which represents the clearance required for the oil film between the rotating assembly and the thrust bearings. Ensure your readings fall within the specified limits. Validate the reading with the factory specifications and document it on the engine build sheet. While at this stage, check the flywheel axial runout. Place the magnetic base on a steel surface and position the dial gauge at the outermost point of the flywheel. Rotate the flywheel, ensuring the value remains below 3.5 thousandths of an inch. A deviation beyond this threshold may lead to clutch problems and engine imbalance. With this out of the way, we have to remove the flywheel in order to proceed with the rest of the rebuild. Next, we'll take the new rear main crankshaft seal and a used custom tool for installation. Next, we'll take the new rear main crankshaft seal and use a custom tool for installation. This specialized tool has 3 bolt holes designed to accommodate the flywheel bolts, effectively pressing the seal into place. The outside diameter precisely matches the size of the seal.
For the next step of this assembly process, I'll focus on the camshaft and the corresponding components. On the BMW/5 motorcycle models, BMW decided to place the camshaft directly below the crankshaft. On some models prior to the /5 motorcycle models, so that's everything pre-1970, you'll actually find the camshaft above the crankshaft. Now let me share with you guys what I laid out on this table, and then we'll start with the assembly process. The first part you'll be able to identify is the stock BMW R60/5 camshaft. After measuring it thoroughly, I figured out it's in excellent condition and therefore it can be reused for the engine rebuild. In front of the camshaft, you'll also find the camshaft flange. This will be fastened to the engine block with 2 countersunk bolts. On the back of the camshaft flange, you'll see an outside diameter that fits snug within the engine block, and the inner diameter will allow the camshaft journal to rotate within it. On the opposite side of the camshaft, you'll have another journal that rotates within the engine block. You want to make sure that the engine block bearing surface is within the factory specifications, and to figure that out, you can use the engine build sheet for assistance. If your clearance is too large, you can run into issues with lubrication, and you can also cause premature wear to your oil pump, which is driven on the rear end of your camshaft. On the camshaft, we also have 4 lobes in total. 2 lobes will be for your intake valves, and 2 lobes will be for your exhaust valves. If we have a closer look at this camshaft, you'll see all surfaces are in pristine condition. There's no pitting and there's no scoring on any of these surfaces. If you do have pitting or scoring, you might want to regrind your camshaft or replace it with a better one. Now over here on the valve tappet, the surface that touches up against the lobe will be the bottom end of the tappet. If your tappet surface looks like this, it can definitely be reused. It's also common that these tappets on the bottom will be pitted or even scored, and that means you're going to have to replace your tappets. But in my case, these parts are still in great condition, so everything can be reused. Next to the camshaft, you'll see 2 woodroof keys. The larger woodroof key is for the front of the camshaft. This will be installed for the front timing chain gear that will be inserted in this area. Now on the back end of the shaft, you'll also have a smaller woodroof key, and this will be inserted in the camshaft, and this will drive the inner rotor of the oil pump. Now with all this said, let's move on to the assembly process. The camshaft assembly was really easy, and now I can focus on the valve lifters, the push rods, and even the valve adjustment screws. While examining the valve tappets, it is crucial that all surfaces are free from damage and smooth, including the area that comes into contact with the push rod. Ensure the surface between the pushrod and the valve adjustment screw is pristine as well. Damaged surfaces in these areas can potentially harm your engine and can cause serious issues. Now with that said, I can install these valve lifters inside of the engine block, and then later on I'll be installing the pushrods and the valve adjustment screws. For the next step of this assembly, we'll focus on the lubrication system of the engine. The lubrication system is crucial for reducing friction and wear between all moving parts within the engine. The oil pump circulates oil throughout the engine to lubricate main components like the pistons, the crankshaft, the camshaft, and everything all the way up to the rocker arms. This will ensure smooth operation of internal engine components, and it also reduces excess heat buildup within the engine. So let's get started with the assembly. Now let's shift our attention to the oil pump, the central component of the lubrication system. Initially, we'll install both inner and outer rotors dry into the engine housing. This step allows us to measure the clearances necessary for the oil pump to create vacuum and maintain proper centering within the engine housing. The first clearance we'll examine is between both rotors, with the factory specifications displayed on screen. Following that, we'll assess the clearance between the outer rotor and the engine housing. I've created a separate video discussing the oil pump rotors, which you can watch by clicking above. If all clearances align with the specifications, proceed with the rebuild. The oil pump cover must be installed correctly, and to do that we'll place the chamfered end towards the crankshaft and the sharp edge towards the bottom of the engine. You can now complete the installation of the flywheel and torque it to the specified value. Before installing it, generously apply lubricant to the thrust bearing and carefully consider the orientation of the flywheel. Here we're looking at the oil canister area. This is the location where the oil filter will be installed, and at the back you'll notice two bores. The left bore is where pressurized oil enters the canister from the oil pump. This oil circulates through the oil filter and then enters the oil canister tube situated in the middle. The top bore is designated for the oil pressure bypass valve. In this image you can observe both the new oil bypass valve assembly and the old assembly. For this engine rebuild, I will use new components, starting with the installation of the bypass valve spring. Ensure the larger end faces towards the engine housing and secure it in place by applying a small amount of assembly lube. Following that, I will install the bypass valve seat and ball. To keep the ball in position, a small amount of grease will be applied to the seat surface. As demonstrated, the assembly remains secure even when turned upside down. Lastly, select an appropriate flathead screwdriver for the tightening process and add a very small amount of medium strength Loctite to the thread of the bypass valve seat. Carefully install these components, ensuring that the ball makes contact with the bypass valve spring. Press and turn the bypass valve seat to securely fasten it in place. Ensuring the valve seat is positioned just below the housing surface. It's also advisable to press the bolt to verify that the valve is functioning as intended, using either a soft metal tool or the back of a brush. While the Loctite will effectively secure the bypass valve seat, I will also use a center punch to mark the housing material. This action will push the aluminum towards the bypass valve seat, creating a locking function. For this task, I will utilize a center punch and a socket extension to reach down into the oil filter canister area. Once finished, it will look something like this. With that out of the way, let's install the brand new oil filter. To ensure a secure seal, tighten and torque the canister cover to specifications, followed by the oil filter cover with a brand new gasket. Moving forward, our focus will be on installing the oil pressure relief valve situated atop the main bearing retainer. On the table, you'll find the valve components showcasing the hollow bolt designed to secure these elements. Beginning with installation, the initial step involves fitting the compression spring, followed by the valve piston. Once installed, ensure the piston moves freely within the hollow bolt. When dealing with a vintage engine over 50 years old, it's advisable to measure the compression spring as it tends to weaken and compress. The old one measures 66.5mm, not its original length. On the flip side, a new spring feels more robust and measures slightly over 68mm, aligning with the factory length. For assembling, a 6mm round tool will be employed to thread the assembly into the main bearing retainer. Before installation, it's crucial to clean the threads with acetone to eliminate all oils before applying high-strength Loctite. Additionally, apply assembly lube to the moving components such as the compression spring and the valve piston. Now proceed to thread in this assembly. On this engine block there are some more oil passageways that need to be plugged. One will receive a brand new oil pressure switch, and the other one will receive an M8 plug. Now that's settled, let's move to the upper section of the engine block to fit the crankcase breather. Warm up the engine block and use a 22mm socket to gently tap in the breather valve body. Place the breather membrane, spring, and circlip in position. Proceed to install a fresh gasket and securely fasten the breather housing to the engine block using exactly 2 bolts. Next, we'll focus on the timing components. I purchased many new parts from Euromode Electrics, and the initial part I'll discuss is the crankshaft timing sprocket. The timing sprocket includes an internal keyway allowing it to slide directly onto the crankshaft key. Once it's mounted on the crankshaft, it will be aligned and positioned. On the outer diameter, you'll observe a total of 19 teeth, precisely half the number of teeth of the camshaft timing sprocket. This holds significant importance because the crankshaft must complete 1 revolution while the camshaft only undergoes half a revolution, establishing a 2:1 ratio. The timing sprocket, featuring a clearly marked indicator enhanced with a yellow marker for visibility, is stamped for aligning the crankshaft with the camshaft, a topic to be discussed later in this video. Rotating it by 90 degrees reveals its double row structure, enabling the installation of a new duplex timing chain. At the center of this table lies a fresh duplex timing chain characterized by a left and a right row connected by an additional chain link in the middle, effectively merging 2 chains into one. On this table I have 2 Masterlink setups. The top Masterlink setup has 1 clip and the bottom Masterlink setup has exactly 2 smaller clips. It doesn't really matter which option you choose, they're both very good, but I will be opting for the top setup because 1 clip is easier to install and that's really just personal preference. I noticed a difference on the chain links when I measured them. Here you'll see this one is 1.6mm thick and the next one to it is also 1.6mm. Now in the other bag you'll see a blue chain link that is 1.6mm thick, and this gray one right next to it is actually 1.4mm thick. So this one on the right is the thinnest of them all, but it was within 1 bag. Consequently, the blue one is positioned externally for easy identification of the Masterlink. I measured the inner chain link, which is closer to 1.58 or 1.6mm, which means the 1.4mm link is a shade thinner than the rest of the chain links. So I will be switching this out for a 1.6mm link, and I will opt for this top setup. I would highly recommend to measure the inner chain link thickness in order to have the right assembly. Adjacent to the timing chain, I have a timing chain tensioner with brand new rubber on it, and it interfaces with the timing chain, ensuring durability. Given the potential wear on an old tensioner over 50 years old, replacing it is advisable. Beyond the tensioner, a fresh spring is essential to apply the correct tension, contributing to a well-functioning timing setup. Additionally, I have a new FOG deep groove ball bearing designated for installation on the crankshaft's inside diameter and secured within the timing cover on its outside diameter. The part number is provided for reference. And right now, I'll start with the assembly process of the crankshaft timing sprocket. Before installing the timing sprocket, I'll thread an M8 all thread into the crankshaft. The significance of this step will become clear shortly. Additionally, I'll lubricate the crankshaft shoulder to facilitate the smooth sliding of the timing sprocket onto the crankshaft. Following that, heat the timing sprocket to approximately 80 degrees Celsius to expand the bore, making the installation much easier. With gloves on, align the keyway of the timing sprocket with the key and promptly slide it onto the crankshaft, ensuring it contacts the shoulder. Position spacers and washers above the timing sprocket, thread a nut onto the all thread and tighten it. This can be left in place until the assembly reaches room temperature, at which point the tools can be removed. To confirm the proper height of the timing sprocket, use a straight edge over the camshaft timing gear for a visual reference. Additionally, check the bottom of the crankshaft timing sprocket and the crankshaft using the thinnest feeler gauge available, ensuring there is no gap. Following these steps will confirm that the assembly has proceeded as planned. To install the new timing chain, wrap it around both sets of timing sprockets. Keep the end of the chain on the camshaft for the installation of the Masterlink. Before connecting the chain links, ensure that the timing marks on the crankshaft and camshaft align perfectly in a vertical position between both sprockets. Proceed with the Masterlink setup, applying a small amount of grease to secure the chain links and facilitate the clip assembly. Install the Masterlink clip with the open end trailing in the direction of rotation, meaning it will be installed from left to right. The chain tensioner will be installed on the slack side of the timing chain to prevent the chain from bouncing and to dampen significant vibrations. To achieve this, I'll lubricate the tensioner's pivoting point and slide it on next to the chain. Proceed by installing the spring behind the tensioner, followed by securing the main bearing retainer nut and threading it on. Remember to torque it to the specified value and install a circlip on the tensioner pivot shaft. Verify smooth operation of the crankshaft and camshaft by turning over the engine by hand. We will install a new ball bearing on the front of the crankshaft to support and center the assembly. For the installation, the inner bearing race will be heated using a sacrificial bearing race as a heat transfer. Once the inner race reaches a temperature slightly above 50 degrees Celsius, I will press it onto the crankshaft using the M8 all thread, washers, and a nut. After a few minutes, I'll remove the tools to check if it sits flush with the face of the crankshaft shoulder. To seal the timing components, our focus shifts to the timing cover and its corresponding components. Let's install two shaft seals into the timing cover. A larger one for the crankshaft, sealing against the alternator rotor, and a smaller one for the camshaft. To ensure a leak-free timing cover, I'll apply liquid sealant on both sides of the timing cover gasket. Let's hope for a leak-free experience in the coming years. The timing cover gasket has only one correct orientation due to the oval cutout on the right side of the gasket. Before mounting the timing cover, it's crucial to heat the bearing area for easy assembly. Once attached to the engine, insert two circular paper gaskets serving as shims for the top timing cover bolts.
one on the left side and one on the right side. Proceed to install all bolts and nuts. Remember, the nuts thread into the studs of the main bearing retainer, while the bolts go directly into the engine block. Exercise caution not to over-torque these fasteners. Now at the lower section of the timing cover resides the RPM pinion gear. This gear is driven by the camshaft timing sprocket extension. Once your engine is running, this tiny gear records its RPMs and transmits the rotational energy to your RPM gauge. Before installing, it's essential to lubricate the entire part. As it pushes into the cover, ensure a distinct feel of how it meshes with the corresponding gear. Additionally, install a thrust washer, the size of which will be displayed on screen. Follow this with a brand new shaft seal, both of which can be installed using a 10 or an 11mm socket with an extension. To secure this assembly, insert the bushing, making sure the cutout faces the threaded bore. This bushing centers the RPM gauge cable within the timing cover, and a small bolt will eventually hold it in place. With all these components in position, the short block assembly is now complete. The timing cover installation went really well, and now I can focus on the connecting rods, and then right after that I'll be installing the engine studs. If you guys would like to install the studs first, you guys can do that. I'll be installing the connecting rods first in my case. Now we'll have a closer look at these connecting rods. You'll see exactly 2 connecting rods on this table because it is a 2-cylinder engine. Now one came out of the right side of the engine and the other one came out of the left side. I'm not going to mix them up. I want to install them exactly the way they came out of this engine. But I'll be installing brand new parts so the clearances are to spec. Now if we have a closer look at this left connecting rod, for instance, you'll see a small end and a large end of this connecting rod. The small end will go towards the wrist pin or the piston of this engine, and on the inside of this connecting rod you'll see a bushing. This bushing has been pressed in and it has been honed to size. It has a specific clearance which I'll leave right here on screen, and this will allow the wrist pin to be lubricated with oil within the engine. Now on the top end of this connecting rod you'll see a bore. This is an oil passageway, so oil can actually reach the wrist pin, and you want to make sure after your bushing is honed to size that you drill this hole. If you do not drill this, you will not have enough lubrication to your wrist pin, which could obviously cause failures. Now if we take a closer look at the crank end of this connecting rod, you will see we have a cap, which is this part, and this right here is a connecting rod. These two parts merge together, and they're also located with 2 dowel pins. On the cap we have exactly 2 bores which correspond with the dowel pins. You actually can't install these the wrong way because the dowel pins are on the exact same side. One thing that can happen is that you take this cap and install it on the other connecting rod, and then take this cap and install it over here, which is obviously not good because you always want to have the same 2 components that go together. You will see on the side of this connecting rod there are actually stampings. This connecting rod and the connecting rod cap have the exact same number. These 2 parts are always machined and ground together, and if you have a different cap you could run into big issues. You also want to make sure that the surface is very smooth because these 2 surfaces will hold 2 brand new bearing inserts. This is a pack that I picked up at Euromote Electrics. They have a full kit, so you'll have 4 bearing inserts for 2 connecting rods. And one thing you really want to do before you install those bearing inserts, you want to take your connecting rod, you want to torque the bolts to spec, and you want to measure the inside diameter. If this diameter is too big or too small, that means you have to adjust the size. Obviously you have to go to a machine shop and they're going to do their magic and make this bore to size for your application. Just be sure these sizes are to the factory specifications, and if you guys need any help, just be sure to check out the engine build sheet because I have all the sizes on there. But right now I think it's time to
grab these parts and install them into this engine. Before installing the connecting rods, it's crucial to guard the engine block surface, which I'll achieve by using this 3D printed part. Next, we'll need to determine the installation direction of the connecting rods, aligning them with the dowel pins towards the front of the engine or the timing cover side. Ensure all surfaces are free of contaminants before proceeding. Subsequently, insert the new bearing inserts, ensuring both ends are flush with the connecting rod cap and the connecting rod itself. Now lubricate the crankshaft journal and the bearing inserts. Carefully place the connecting rod cap, ensuring only the bearing insert touches the journal. Apply a small amount of assembly grease under the connecting rod bolt head to help even torquing of the bolts. Gently mesh the two parts, ensuring the dowel pins are correctly seated within the connecting rod cap. Hand tighten the connecting rod bolts using a 12-point bit, and then proceed to torque the bolts according to the specified values. After torquing the bolts, verify that the connecting rods rotate smoothly and the axial play is minimal and within specifications. If there's a hint of sloppiness or looseness, it could indicate excessively large clearances. If everything feels good, turn it over by hand and continue with your build. Proceeding, we will now install the engine studs. For this task, I will use a premium jam nut stud tool, assisting with the threading of the studs into the engine block. It's crucial to establish the depth of threading into the engine block, and for this purpose I will use a combination square set to 10 inches or 254 millimeters. To enhance the reference, I've marked the 10-inch point with tape. Prior to installation, the studs have been stored in the freezer overnight for an easier install. Ensure that the studs thread in by hand initially and snug up after 1 to 2 turns. I recommend against using hand taps to recut the engine block threads, as they were initially cut with an undersized tap. Now gradually tighten the stud tool and begin threading it in, ensuring a smooth process without any binding. While it may be a tight fit, this is the intended outcome. Verify the depth using the combination square and proceed to install all other studs, ensuring they are all of the same length. Upon completion, your engine block should look like this. Now the studs are threaded into this engine block, and I can move along to the cylinders and the pistons. There's a lot on this table to cover, so let's get right to it. On this table, you'll see a lot of brand new parts. On the far left, we have brand new gaskets that were supplied within the gasket kit. Up above, we have seals that go on each pushrod tube. Those seal between the pushrod tubes and the engine block. In the middle of the table, you'll see brand new pistons. The standard size piston for the R60 is 73.5 millimeters in diameter, and these right here are 74 millimeters. Technically, it's not the piston that's that size, but it is the bore size. So that's actually the volume of your engine. The pistons are just a shade smaller because it has to be a clearance. Now, those pistons were purchased through EME, and those are also Mahle pistons, so they should be pretty high quality. Now on this table, you'll see 3 rings that were actually originally on the pistons. That's the way Mahle ships them, but I took them off because I need to measure the end gap within the cylinders themselves. Then right there, we have a wrist pin for each piston, obviously, and then we also have 2 clips to hold the wrist pin in place within the piston itself. So 2 pistons, 2 cylinders, and everything on this table is pretty much brand new. If you guys would like to install your pushrod tubes, I already made a separate video on that, which you can find right here up above. I covered the whole disassembly process. So these pushrod tubes are brand new, and they're also stainless steel, which is an upgrade from the original cadmium plated pushrod tube. The cylinders that I have in front of me have already been at the machine shop, so you'll see the inside diameter has been machined and honed to accommodate the brand new oversized pistons in front of me. Under pistons, you will see we need a specific clearance, and that will be listed right here. The left and the right piston have the same clearance, and that right there is the imperial spec, and this right here is the metric spec for your clearance between your piston and your cylinder. Now, if we have a closer look at the piston rings, we have to measure the end gap, which is this gap right here. Once you take the piston ring and install it into the bore, you need a specific gap. There's obviously a range, but it can't be too large or it can't be too small, or else you'll run into issues. Once all the end gaps measure correctly, we can then install them back onto the pistons, and then we also want to check the side clearance of each ring to the piston. If you guys have a good look at the engine build sheet, you'll see everything right here. So you have your first compression ring, your second intermediate ring, and then your third oil control ring. But also take in consideration the R50 and the R60 are very similar, or they are the same, but the R75 is a little bit different. So if you guys have a larger engine, be sure to check these specs. If you guys have a smaller engine, check out those specs. The first thing I'll do is check the end gap of each piston ring within the designated cylinder. Now this piston will be designated for the right cylinder and this piston for the left cylinder. Even though these are honed to the exact same size, I don't want to mix them up because one will be the right piston and one will be the left piston, and I want to keep it that way. Now if we have a closer look at the top compression ring, you'll notice something right off the bat. You'll see this chamfer on the top compression ring, and it's also the same on the other side. So before I install any piston ring into the bore, I always want to make sure that there's no sharp edges towards the cylinder wall. But if we have a closer look at piston ring number 2, you'll actually see there's no chamfer right there. So if I take this on a piece of paper, you'll see exactly what this will do. I'll begin by rubbing the chamfered edge against the paper, leaving minimal damage. Moving on to the second intermediate ring, it appears more abrasive on the paper, almost wanting to dig in. I strongly dislike those sharp edges as they can damage a cylinder wall. To address this, I'll use a flat file and emery cloth to remove them, aiming to create rounded edges and achieve a smooth transition. Next, I'll insert the first piston ring into the cylinder bore. I avoid using the piston to square up the rings in the bore for the end gap verification, as the pistons are smaller than the cylinder bore and have features that don't align flush with the piston ring. Instead, I prefer using a depth gauge set at around 1/2 inch or 12 millimeters. Placing it in position, I'll use feeler gauges to check the end gap and ensure it falls within specifications. All the piston ring end gaps on this table met the specs, but I still found the sharp edges undesirable. If your end gap is too small, remove some material from one side and recheck the gap. If it falls within spec, proceed with the assembly. Next, we'll proceed to install the piston rings, beginning with the oil control ring and moving upward. Correct installation of the piston rings is crucial, and their direction is indicated by a top mark. Ensure that this mark faces the top of the piston. Apply oil to the piston ring grooves to lubricate the rings for the assembly process. Carefully expand the piston rings using a piston ring expander, releasing them slowly when they align with the groove. Gently compress the ring with your fingers, ensuring it moves freely all the way around the piston. This step is vital as piston rings rotate within the cylinder bore, and any binding effect should be avoided. Continue the installation process by fitting the remaining piston rings.
Now for the next step of this assembly, we'll be installing the pistons into each cylinder bore. It's really important that you get the direction of piston right because there is an arrow stamped on this from factory. So the arrow goes towards the front of the engine, which is the opposite side of the flywheel. I also indicated this with a red marker, so it's a little bit more visible for you at home. Now the reason why they did this is the connecting rods within this assembly are actually a little bit offset. They're not perfectly in the middle of this piston. So on the bottom of this piston, there will be a little bit of extra weight on one side, and that is just to counterbalance the offset of the connecting rod within this piston. Prior to the assembly process, we also have to take the piston rings into consideration. Now there are exactly 3 piston rings: the oil control ring, the intermediate ring, or the second compression ring, and then the top ring, which is the first compression ring. Now you'll want to make sure that the end gap on all these piston rings is about 120 degrees offset. Now what's really important to know is that if you put this engine or your bike on a side stand and your oil control ring, which actually holds in your oil and also distributes the oil throughout the top end of your engine, is on the very bottom of your bore, it's very possible that you'll have oil seeping down closer to your cylinder head. So then you'll have a lot of oil there, and then once you go and start it up, you'll have a lot of white smoke. So what we're going to do is place the oil control ring, which is the one closest to the bottom. We're going to have that on the very top of the cylinder bore. Now if we have the oil control ring at 2 o'clock, you want to make sure that the second intermediate ring is at 10 o'clock. So you want to have them about 120 degrees offset. Now if we have a look at the very bottom, you'll see the end gap of the first or the top compression ring. Now this would actually be at the very bottom in the middle, but we don't want to place it directly on the bottom, so we're going to just offset that by around 5 degrees, either to the left side or to the right side. It's really up to you. Now these piston rings are exactly where they should be. Now let's install them into the cylinder bores. Clean the cylinder bore surface and apply enough oil or assembly lube around the area. Lubricate the piston and keep in mind correct orientation of the piston you're installing. Position the piston in a piston ring compressor tool and seat it onto the cylinder. Ensure proper alignment of the wrist pin bores on both sides of the cylinder. Then use a wooden drift to gently drive the piston into the cylinder. Press down on the compressor tool to secure it to the cylinder and carefully observe how the piston rings enter the bore. It's crucial to avoid damaging any rings during this process. Remove the compressor tool and the assembly should look like this. The piston rings are now fully seated within the respective cylinder bores. I still left about 3/4 of the piston sticking out on the back end of this cylinder, and that way I have access to the wrist pin. This will allow me to install the wrist pin within the piston and merge it with the top end of the connecting rod. Now also, before we grab this assembly and slide it over the 4 studs, we have to install brand new pushrod tube seals. These will go directly on the pushrod tubes, so I'll be installing them on here. Before I do that, I also need to install this brand new soft metal gasket, which will seal between your cylinder and your engine block. You really want to make sure that there's no burr on this soft metal gasket. It feels kind of rough, especially around the edges, so I'd really make sure that there's no burr or anything sticking up, and if there is, you can just take a small file and just file that off. Now once you verify that your surfaces are nice and smooth, you can then place it on your cylinder. You also want to make sure that the surface on your cylinder and the surface on your engine block are perfectly flat and smooth. That way it'll be properly sealed. Some engine builders even recommend that you place a bead, a very, very, very thin bead of Hyalomar silicone on either side of this gasket. I personally don't like putting silicone on any gasket, especially on the front or the back. Now for this gasket, I'll probably apply a thin layer of the liquid sealant I've
I've been using for some of the other paper gaskets. It's an anaerobic sealant, so what that means is it'll only harden or cure within two surfaces without any air. Everything that's actually sticking out or whatever pushes out once I torque everything down will actually not harden or cure properly. So I think that's what I'm going to be using for this assembly, but I'll have to do that later once I get to the torquing stage of the cylinder head. But right now, let's slide these cylinders onto these engine studs. Grab your cylinders and slowly slide them onto the engine studs, making sure the connecting rods are placed into the pistons. Line up the connecting rod bore with the piston wrist pin bore. Lube the wrist pin and corresponding components and slide it through all parts. Leave a small gap in order to install the wire lock clips. I'm also using a piece of shim stock to act as a guard while installing the wire clip. Be sure it's fully seated and then push in the wrist pin all the way to install the second wire clip on the opposite side. There are two more cylinder studs that will be installed on each cylinder, and I'll thread them in now on both sides with the Runout installation tool. For the next step of this assembly, we'll focus on the cylinder heads. We're going to have to install the valves and the corresponding components on this blue sheet down below, so let's get right to the assembly. I'll be installing new valves into the cylinder head, which has undergone processes like new valves, valve seat reconditioning, and cylinder head resurfacing at the machine shop. To ensure precise valve guide fitment, I'll install the valves dry initially, as they need to be accurately honed to size, to prevent poor performance and premature wear of the valve stems. If everything feels good, start by lubricating the valve stem and installing them into the cylinder head. Moving to the top end, I'll install the lower spring plate, ensuring well lubricated surfaces. Then I'll add the valve spring with indicator marks in blue facing towards the cylinder head, and include the upper spring plate in the assembly. To keep this assembly intact, I need to install the valve keepers. Ensure the valve keepers rotate on the valve keeper grooves, since valves tend to rotate within the assembly. Using a generic valve spring compressor tool, I'll compress the assembly, add a small amount of grease to the valve keepers, and install them into the grooves. Once fully seated, I can release the compressor tool and the cylinder head should look like this. Now before I just go and mount these cylinder heads onto this engine, there are a few more parts on this table that I want to discuss, and I'll also be discussing the rocker arm assembly, then we can assemble everything. On this table I have a complete set of 8 rocker arm support O-rings and 8 sleeve spacers. These O-rings will serve as seals for the upper oil passageways when placed directly on the cylinder head, and the lower O-rings will function as spacers. The spacer sleeves will maintain the distance for the rocker arm assembly that is secured onto the cylinder head. I've added a few more parts to this table which make up the rocker arm assembly. This rocker arm assembly will be mounted on the cylinder head, and once everything is on the cylinder head, it will be torqued to the engine block. So we really want to discuss this now because once it's torqued down, it'll be a little bit harder to focus on each part specifically. So in the middle of the screen, you'll see a rocker arm shaft. Now below this, you'll see a thrust washer, and below that, you'll see the support block that holds the rocker arm to the cylinder head. Above, you'll see a thrust spacer. This will be mounted on the top end of the rocker arm. And then on the very top, we also have another support block, which will hold this whole assembly to the cylinder head once again. Now, if we focus on the rocker arm assembly, you'll see the rocker arm shaft directly in the middle. This rocker arm shaft features exactly 2 bores, which will allow us to place this rocker arm shaft on the engine studs. The rocker arm shaft will be placed in a vertical position, and it's really important that you place this on the studs the right way. There's an oil passageway within this rocker arm shaft. That oil passageway has to be facing upwards. The oil will be running down from both top engine studs, and it will lubricate the rocker arm that is placed on this rocker arm shaft. So the oil passageway has to be on the top of this assembly. It's really important that you do that. On these rocker arm shafts, we will be placing a rocker arm. In my case, the bushing is already inserted into the rocker arm. The original assembly had a clearance between the bushing and the rocker arm, and a clearance between the bushing and the rocker arm shaft. Now the bushing in my case does have the clearance to the rocker arm shaft, and it also is honed to size. You really want to make sure this is to spec, that your bore is an oval, that it's perfectly round. You could have an extra bit of slop within your bushing, and that means you have a loose top end, which would obviously cause more wear and vibrations. Now on the bottom end of this assembly, we will have a thrust washer. This will be placed in between the rocker arm itself, so it'll go up against this surface. It'll be pushed up against the rocker arm, and then we will have this support block that will be pushed onto the shaft just like that. I've noticed that these support blocks were oval, so I also sent these out to the machine shop and they honed the inside diameter. Now it is a true circle again. Now this support block will be mounted on the rocker arm shaft just like this, and it will line up with the bore for the engine stud. So in between the support block and the rocker arm, we will have that thrust washer, and that will keep a space between the block so the block does not wear out as quickly. Now on the top end of this assembly, we'll have a thrust bushing, and this bushing will be inserted on the top end just like that. On the very top of this assembly, we'll have another support block, and this will be mounted onto the shaft just like that. And when we look at this assembly, you'll notice the bores line up perfectly, and now this assembly is ready to be installed. I got all the rocker arms together, and now it's time for the assembly process, so let's get right to it. Before installing the cylinder head, generously apply assembly lube or oil to all major components. Additionally, use a small amount of liquid sealant on both sides of the base gasket to prevent potential oil leaks. Ensure the pushrod tube seals seat properly in the respective tapered bores of the engine block as you push the cylinder toward it. Afterward, install a new head gasket and slide on the cylinder head. Lubricate and install the pushrods. Lubricate and install the pushrods. Position the rocker arm assembly over the engine studs and hand thread the cylinder head nuts on. Lubricate these nuts before mating them with the studs. Gradually and evenly tighten the nuts until the base of the cylinder makes contact with the engine block housing. The next step involves focusing on the rocker arm adjustment before torquing the cylinder head nuts. They should be parallel with even spacing. Support blocks will maintain the correct distance for the rocker arm parts, and it's crucial that the rocker arm fits snugly within the assembly. Aim for minimal axial play while ensuring the rocker arm can move smoothly on the shaft. To maintain a tight fit, gently clamp these support blocks using 2 sockets and access the rocker arm's feel. Proceed to hand tighten these nuts to approximately 10 Newton meters. Once all rocker arms are set, you can proceed to torque the nuts with a torque wrench, taking the torque sequence into consideration and the rocker arm play. Follow this 3-stage torque sequence and you should be just fine. The cylinder heads have been torqued to this engine block, and now it's time to adjust the valve clearance. That is the clearance between the rocker arm and the valve stem. Based on this engine drawing I have behind me here, you'll see the intake valve clearance and the exhaust valve clearance that BMW specified even back in the day. With these values, we're going to adjust the valve clearance right now. To start, I'll install new valve adjustment screw jam nuts into the assembly, ensuring sufficient clearance on the rocker arms to turn over the engine. Rotate the engine counterclockwise on the flywheel to reach top dead center on the compression stroke marked as OT seen through the timing hole. The intake valve clearance is 0.15 millimeters and the exhaust clearance is 0.20 millimeters. Adjust the clearance by turning the adjustment screw. For this demonstration, I'll focus on adjusting the exhaust valve. I'll verify the clearance, assess it if it needs adjustment, gently snug up the jam nut, and make small incremental changes for the desired clearance. After tightening the jam nut, double check the clearance and torque it to the specifications. Rotate the engine once or twice to recheck the clearance, and repeat the clearance adjustment for all other valves using the appropriate feeler gauge. To seal the top end, install new valve cover gaskets between your cylinder head and valve cover. This valve cover is tightened with a central acorn nut, which will be torqued to spec, and 2 smaller 10mm nuts for each stud. Install the exhaust nuts once the exhaust manifold is inserted, ensuring not to overlook the exhaust thrust ring positioned toward the cylinder head and the exhaust clamp ring closer to the exhaust nut. Thread this assembly onto the cylinder head and generously apply copper paste as an anti-seize agent. I will utilize NGK BPR 70S spark plugs for a prolonged spark duration thanks to the integrated resistor. I'll install them without using copper paste, and I will torque to approximately 90 Nm. Exceeding this value may damage your cylinder head spark plug threads, so be very careful. A few more parts have to go back onto this engine. Most of the parts in the middle of this table will be mounted on the timing cover side of this engine, which is the very front. And then over here on the right, I have the starter, which will be mounted on the very top. So let's get right to this so I can share the final results with you. When installing the alternator, it's crucial to clean the crankshaft taper with acetone and the inside taper of the alternator rotor. Apply a thin layer of assembly grease to the outside diameter, which will interact with the timing cover shaft seal. Slide the rotor onto the crankshaft. If it feels snug, your surfaces are very likely clean. Proceed by installing the special alternator rotor Allen bolt and torque it to specifications. To prevent the engine from rotating, place a small pry bar on the starter ring gear and then torque the Allen bolt down. Next, install the alternator stator and lift the brushes over the alternator slip rings. Tighten all 3 stator bolts and this assembly is complete. Now let's direct our attention to the ignition advance unit assembly. Among the various parts are the cam with pivot posts, the cam plate featuring 2-sided posts, two weights, 2 fiber discs, 2 circlips, and 2 springs. Within this bag are 2 springs from EME intended to enhance the overall performance of the ignition advance unit. Commencing the assembly, I'll position both fiber discs on the back end of the cam plate over each post. This ensures a space for the weights, preventing metal-to-metal contact. Before securing the weights, let's add the cam to the cam plate and proceed with installing the weights, followed by 2 circlips to hold them in place. On the front side, install 2 new springs between the posts and eventually the assembly will take on this appearance. Next, we'll proceed to install the points plate using 2 flathead screws and 2 ribbed lock washers. The points mechanism will naturally align itself on the points plate through a small pin. Secure the top half of the points plate, positioning the wire and points rubber hose shield toward the top of the timing cover. Moving on, install the ignition advance unit, aligning it with the flat of the camshaft to the cam plate. Exercise caution while torquing down the assembly. Personally, I performed it in 2 stages to ensure gradual and controlled tightening of the nut. To complete this assembly, install the points plate seal strip and secure the points wire with this wire clamp. The points wire feeds into the condenser positioned and secured above the alternator. Install the starter motor atop the engine using 2 larger bolts. These bolts will firmly attach the starter to the engine block and support a small wire clamp securing a plastic starter guard. Ensure the starter motor is properly aligned with the ring gear and torque the bolts to the specifications. At the rear of the starter motor, secure the bracket with a small hex bolt that threads into the engine block. To install the new wiring harness, secure the grommet in the timing cover cutout and attach all necessary terminals to the corresponding connectors. Now to seal off the front of this engine, install the alternator cover and tighten 3 bolts. For the last part of this assembly, we'll mount the air intake scoop onto the starter cover and hold it in place with a spring clip. Place the starter cover onto the engine and apply your engine identification badges. If you made it this far into the video, I want to thank you so much for watching the detailed engine assembly video. It's taken a long time to get to this point, but I'm finally done and now I can work on other aspects of the BMW R60/5 motorcycle project. If you want to support this channel, be sure to subscribe, hit the like button down below, and also turn on your post notifications so you won't miss out on any upcoming videos. In addition to that, you can also support me by checking out my website and picking up an engine poster like the one I have behind me here. If you're craving more workshop rebuild content, be sure to watch this video next. And remember, keep the conversations going down below in the comment section. Stay awesome, take care, and I hope to see you guys in the next one. Peace.